The question number 31 is, if in a SHM x the displacement a is the acceleration at any time t, the plot of a and x. You know that the standard condition a is equal to minus k into x. So this is like y is equal to minus mx. So this is the equation of a straight line passing through the origin, and your graph will be a straight line. So the correct option is the second one. Question number 32 is, in simple harmonic motion at the extreme position, kinetic energy is maximum, potential minimum, and these are four options. See, when the particle is executing SHM, let's say the potential energy at mean position is 0, then the expression is 1 by 2 k x square, and for kinetic it is 1 by 2 k a square minus x square. So at the extreme position, that is at a and minus a, the kinetic energy becomes 0. The graph is like this. And for potential energy, the reverse graph is like this one. Now what is required? The kinetic energy is maximum at the extreme position. At the extreme position, the potential energy is maximum and kinetic is minimum. So at the extreme point, the kinetic energy is minimum and potential energy is maximum. Therefore, the correct answer is option number 2. Let's look at the question number 33. A block of mass m hangs from 3 springs as shown in the figure. If the mass m is slightly displaced downward, then the time period of oscillation. So dear student, we have to find the k effective. Now see how to find k effective. This is 3k and these two springs are in parallel. So when two springs are in parallel, the effective constant, so 3k plus 3k is equal to 6k. And this is the mass attached. Now, since both are in series, the k effective will be equal to 1 by k1 plus 1 by k2. So the effective k will be equal to 3k into 6k divided by 3k plus 6k, and that is equal to 2k. So effective spring constant is this, and what is the time period? T is equal to 2 pi the mass oscillating divided by k effective, and k effective is 2k. So it is 2 pi m divided by 2k whole root. And the search the option number 4 is 2 pi root of m by k. So answer is 4 to this question. The question number 34 is, a 10-meter long string wire has a mass of 5 gram. The wire is under tension of 80 Newton. The speed of the transfer wave. Now dear students, when this string is under the tension T and nu is the mass per unit length, then a transfer wave velocity is equal to T divided by mass per unit length. And see, the tension is given 80 Newton. And what would the mass per unit length? Mass is 5 gram, 5 by 1000, and the length is 10 meter. So this becomes 5 into 10 to the power minus 4 kg per meter. So fill up here, then velocity become 80 divided by 5 into 10 to the power 4 goes up. So 16 into 10 to the power 4 whole root, which is equal to 400 meter per second. So the correct option is the 4. The question number 35 is, a source of sound producing wavelength 50 centimeter is moving away from a stationary observer with 1/5 of the speed of the sound. The wavelength of the sound received by the observer. Now see, this was the observer and this is the source. The source is moving away and the original frequency was equal to v1 lambda. When the source moves away, then the wavelength will change. It's given that the velocity of the source is equal to v divided by 5. And per second, what is this distance? This is v plus vs. And what will be the apparent wavelength? That is equal to, because moving away, then v plus vs. If it is approaching, then it is v minus vs. So this become v plus v source divided by n. This is the apparent wavelength. Then v plus v by 5, and n is what? V by lambda. So v upon lambda. So this is lambda into 6 by 5. Originally is 50 centimeter into 6 by 5. So this comes to be 60 centimeter. If the apparent wavelength will increase and frequency decreases, Your option is 2.